All right, so first, I don't know if you can hear the hail in the background, but ignore it. So the first thing says, what is the derivative of the vector v squared? Well, this can be rewritten as the derivative of v times v. And since both of these are in terms of t, they're functions, when you do the derivative, you have to do the, I forget the name of it, but you have to do like dv dt times v, so the derivative of the first thing times the second, and then plus v times dv dt. So in other words, you know, this is first derivative of the first function times the second function plus the first function times the derivative of the second function. They just both happen to be the same. Notation-wise, v with a dot above it means the derivative with respect to time once. So if I do the derivative of v squared, you'll get v dot v plus v times v dot. And you can add those because they're the same. So you just get 2v times v dot. Okay. For the second one, we've got to do the derivative of this, remembering that k is a constant. And so to do this, you essentially just do the same thing you did up here, but do it twice. So the first time, you're going to do the derivative of the first function times the second, so dv dt times k, and then just reverse it, plus the first function times the derivative of the second function, so v times dk dt. And then you still have this v out here, which we haven't gotten to, so we'll just leave it there. Now, this function here, that's 0, because k is a constant, so this derivative is going to be a constant. Or sorry, it's going to be 0. All right, then we do plus. Now we just take the derivative of this function, or sorry, we just take this function and multiply it by the derivative of this, which is this part right here. So I just rewrote that, but then multiplied it by the derivative. So altogether we have 3 terms because there's 3 things here. So we essentially just did this same thing, but 3 times rather than twice. So rewriting this, we get dv dt can be written as v dot k. This is 0, so 0. We still have this v out here. Then, just rewriting this, v plus k times v dot. Cleaning it up a little bit more by getting rid of the 0, you just get this. Okay, lastly, it wants to know what ddt is of this thing. Now, I had to look this up because I didn't recognize this notation with the bars. That's apparently called the triple scalar product, which means this. So this dotted with the cross product of this and this. And I think it was on, let's see, I have the book in front of me. I can send you a PDF copy of the book if you want. But on page 15, they talk about this. And they said a very specific rule is this is 0 if one of 2 things occurs. If there's a 0 in one of these, or if 2 of these vectors are the same. Okay, so this function will be 0, or this triple scalar product will be 0 if 2 of the 3 of the vectors are the same, or if one of them is 0. Okay, so now we got to do the derivative part. Well, the derivative part is actually quite simple. You just take the derivative of the first term, then take the derivative of the second term, and then take the derivative of the third term and just add them together. So for example, for the first one, I take v, it becomes v dot. And then I just rewrite the others. So v dot, derivative of the first term, second term, third term, plus rewriting this first term, v, taking the derivative of the second term, so now we have v double dot, and then rewriting the third term, plus the first term, the second term, and the derivative of the last term. Now, this is 0, like I said, because these 2 vectors are the same. This is 0, because this k derivative is a constant, so that's going to be 0. So this triple scalar product and this triple scalar product are both 0 because of what I said. So all we have left is just this, so that's our answer.